Good morning. Can you all hear me?
Yes.
Yes.
Okay, good. Before we discuss the homework, I'd like to discuss the final exam with you. The final exam, I plan to follow the university rules. You know, I think you all received the guideline from the provost. So internally, the School of Engineering also discussed. So we like to have a relatively uniform procedure. That is, we're going to have the exam at the regular time. That is May 6th at 8 o'clock in the morning, 8 a.m. Wednesday morning at 8 a.m. in 2 weeks. And because last time we had too many problems with proctorium. So I'm going to give it up. I believe it has been approved. So I'm not going to use proctorium. Okay, no proctorium for the final exam. And it's not going to be cafeteria type. It's going to be 3 hours for most of you. For those who would like to start early, you can start at 7. I will release the problem at 7, but for most of you, you have to submit it in 3 hours. I don't think I'm going to trouble you with a lot of problems. Okay. So the exam will be, for most of you, you can start at 8 o'clock. If you really want it, you can start at 7. So 7, make sure you submit it in 3 hours. When you submit it, it's going to be stamped. Your answer sheet is going to be stamped. So we're going to check that. On the other hand, I'm not going to give you a lot of problems. You should finish well before the 3 hours. So this is the deal. For those who join us a little late, let me say it again. The university rules is the final exam, we're going to follow the university time, 8 o'clock on May the 6th, Wednesday morning, during the final exam week. If we want to change that, we're going to have make special requirement, a special request. It's a lot of hassle. And we're not going to use proctorium. So when you log in to your Blackboard, you're going to see the problem starting at 7 o'clock in the morning. For those who need extra time and are approved by the university, you can have 4.5 hours. So the time, the stamped time will be a reference point, but I don't think you need that much time. Okay, anything about the final exam? Any concern about the final exam?
How many questions is it going to be, Dr. Chen?
I don't know. Good question. I don't know yet. Yes.
Is it going to be cumulative or just on the material since the last test?
Say it again, please.
Is the final exam cumulative? What does it cover?
It's going to cover whatever, I think you ask a central question. We are in the right pace before the spring break, but we got too many interruptions. You know, the centerpiece of this course is partial differential equation, and we have not getting into that yet. So I'm eager to get into the subject of PDE so that at least you get a flavor how to solve a PDE. So I already created 2 segments of video and it's being uploaded. Please start watching it. This gives you a flavor of what PDE separation of variable are. They are useful for solving partial differential equations. So I urge you to start watching in the next few days. So to answer your question about what will be covered, I think we're going to cover up to chapter 12. As far as where it ends, I don't know. I don't know. I will be reasonable. So I need your cooperation too. So maybe the first, I already assigned homework for next week. The first 2 lines of, let me see, the first page 542, 560, no, 542, 551, and 566. I don't think I have. Let me check. For the heat transfer problem, I think most of you will take heat transfer class somewhere before you get out of here. And your teacher will definitely mention separation of variable. That's the technique we're going to discuss. If your heat transfer teacher brand me, I didn't teach it, I'll be in trouble. So I'm interested in creating at least another video footage that will cover, let me make sure before I say that, section 12.5 and 12.6. I'm hoping this is the target, but we shall see how it goes, okay? Because most of you are mechanical engineers, and the heat transfer will be important for you. That's why I want to cover at least something about heat transfer. To 12.6, remember I skipped 12.4. I'm going to skip 12.4. Yes. So, this is the plan, but we can discuss more next week. We have one more week, right? Yeah. Let's discuss next week. I think we can achieve this goal, at least to 12.6. You know what the separation of variable to solve PDE. That's the highlight of this course. Is this okay? Maybe you shouldn't answer this question, but think about it in the next week or so, so we can discuss more next week. I'll be reasonable. Okay. Anything else about the final exam?
Dr. Chen, did you say it was going to be using Proctorio, or was it just going to be on Zoom?
I'm not going to use Proctorio. I mentioned to our school, and I don't see any objections. We were instructed to use it last time for the second exam, but now a lot of professors are complaining the trouble. We want the exam to be fair, but it turned out it's not fair for the people who did it. So we decided not to use Proctorio. And we have 3-hour exam window for most of you. Okay.
Awesome. Thank you, Dr. Chen.
Yeah, you're welcome.
When is our test grade gonna be in? Do you know?
The exam time?
No, our when will our test 2 grade be in?
On May 6th.
No, like our grade for the test we took.
Can you
Last week's test.
Huh?
When will our grade for the test we just took be given?
Oh, the grade for your second exam?
Yes.
I will push.
Yes, sir.
I will push the TA a little bit. Okay. The TA, the good TA is also an undergraduate student. He's good, but we have the trouble is we have another student, another TA who is not doing any work. He just refused to do any work. Oh, that's my difficulty. I'm using my personal fund to support the TA now, the good TA. So I'm going to push him a little bit. Only last week we got the funding issue resolved. I will push him a little bit after this session. Okay. Oh, you
So like maybe like next week.
for sure, yes, for sure. You know he has his
Okay,
own.
thank you.
He has his own exam too. That's the difficulty. Anything else about the final exam? I forgot to mention, do you want to see the solutions for the exam? Did everyone?
Yes, please. Can we see the solutions to exam 2?
Okay, let me see if I can open it.
Dr. Chen, are you going to upload the, like you're saying, the exam 2 answers? Are you going to upload them on Blackboard as well so we can go back and review them for the test or review them for the final?
Let me see if I have them. Just 1 minute. Exam 2. I believe it was our policy to discuss the solution, but not put up the solution on the Blackboard. That's the difficulty. I don't remember where I should have the solution, but I couldn't find it. Okay. I found it. I can share with you. Essentially, it's like Blackboard because I'm recording this session. You should just 1 minute. Let me share the screen. Solution to exam 2. Do you see it? Do you see the problem and the solution?
Yeah, I can see it.
Okay, good.
Yes, I can see it.
Okay. So this problem, we are asked to solve this differential equation. We can tell chapter 2 will not allow us to solve this problem because it doesn't have constant coefficients. So we have to rely on series. And it turned out it's a Frobenius series problem. And so we get 2 roots of the indicial equation. Let's see where. The Frobenius series solution look like this. And the 2 roots of the indicial equation is a positive 1 and negative 1/2. So it's a case 1, case 2, or case 3 problem. It's a case 1 problem. You agree? So it's relatively easy to solve a case 1 problem because you can create a table. So you can use the same table for solving y1 and y2. This is my answer. Y1 look like this, Y2 look like this. Okay. Did you get it correct? Yes.
Not even close.
No, sir. Not close.
I mean, I got the roots, but I didn't get the answer no.
Oh,
Yes, me neither.
okay. What is the difficulty?
I wasn't able to get the roots. So I got like one of the roots, and then yeah, I think I came up with like 1 and
You got this?
1/2 were my
Yes,
roots.
I got that.
And
So it's a case 1. You can
It's a
create the table.
It should be a case 2.
It's a case 1 problem. They don't differ by an integer.
Oh, yes, yes. Yeah, I think I got the equation and the roots, but after that, I think my table was not right, and I did some mistake. I don't know.
Yeah.
yeah, I think I came up with
Yeah.
like y. When I did my table, it was y = 0, and then time just ran out. I just couldn't finish it.
This
Or
is,
y1 = 0,
Yeah, I think I got the same.
and then I knew that wasn't right. So
this is the recurrence relation.
yeah, I got to the recurrence relation, and then and for y1 was 0, and I knew that wasn't right, and then yeah.
Okay. I will talk to the TA and see what his grading policy is. To me, if you get the recurrence relation, you get more than 50% of the points. Probably 60. I don't know. I will discuss with him.
Okay, sir. Thank you.
Yeah. So for the second problem, we are asked to transform a equation to a Bessel. We are asked to change the independent variables only. And this is very similar to the example I leave in the study guide. And you did homework on this.
Yes.
Yeah, this one was a lot. I thought number 2 was a lot easier because it wasn't as long. So number 2 I got right because
Okay.
that one was just like the homework that we did, almost identical to the homework. And then there was 1 or 2 questions in the study guide that made this super easy.
Yeah,
Okay.
I did. I think I did good on number 2 also.
Okay, very good. So the final exam can be more difficult than this?
No.
Oh, thank
Okay.
you.
Okay. Now, can we start discussing the homework?
Yes, please.
Okay. Did someone send me a message? No. I have a message somewhere, but don't worry. Okay, how is the homework going? I know we have a terrible week. So did I. So I can understand your feeling.
Yes.
So any questions, any discussion about the last 2 lines of homework problem for chapter 11? Page 509, 517.
Yeah. When on for section for page 509 homework, the first problem, I'm trying to figure out where you're getting or where the book is getting the 3 over 2x squared minus 1/2 portion of it. I mean, I just don't know where they're getting the p of x portion of the expansion.
You mean the first problem on page 509?
Yes, sir.
Okay. So the given function is this line 63 times x to the 5th power minus 90 times x cubed plus 35x. So this is a given function, f. And we want to represent this by Fourier Legendre function. So what does that mean? What does that mean? Fourier Legendre, you can tell from my screen, we want to represent, this is standard Fourier series representation, but since the Legendre polynomials are also Stallovsky problem, so all the Pn forms a orthogonal set of functions. If they are orthogonal set of functions, we have this property, of course, and then for any arbitrary functions, f, we can represent, let's see, where is, yeah, this is the general formula. If y in this representation, ym, is an orthogonal set of functions, we can represent a given function f by this orthogonal set of functions like this. Then the coefficients can be obtained by using this formula. So the given problem is if ym in our problem is orthogonal, is Legendre polynomials. If ym is Legendre polynomials, and we want to represent this given function in this section by Legendre set of functions, the remaining question is to get the coefficient. And the coefficient can obtain based on this formula. So I believe the author even derived the integral for us for Fourier Legendre. Yeah, it's right here. So if we have Legendre polynomial here, this is a given. So our job for this set of homework problems is to get the coefficient by using this formula. This is all you need to take to prove. You can get AM and plot them out to see if you include more terms. If you include more terms, the more accurate the result will be. Now you may ask me where the where you can find the Legendre polynomial. I mentioned on this slide, it's on page 178. I think up to P sub 6. Let me see, 178. Page 178, you need, yeah, we have up to P sub 5. So up to 5th order polynomial, the polynomial given. So P9 is 1, P1 is simply x, P2 is this function. So in order to get A sub 0, A now, you put the 0 here, you put the P naught here, that means 1. You just integrate the given function from -1 to 1. For A sub 1, you put the 1 here, then you integrate the product of the given function with P1. That is x. You can integrate fairly easily. So this is the way to do it. I suggest you do 3 terms, at least get 3 terms. I know this is the reason I ask you to learn MathCAD. If you have access to MathCAD, this is a piece of cake. You put this integral in, let MathCAD do all the hard work. Before you have a chance to zip some coffee, the answer is already on the screen. You cannot catch up. Okay, so so this is the way you get the coefficient. Now, I don't think you have access to MathCAD, do you? Some of you may have. You will be allowed to use MathCAD. Okay. So for the problems on page 509, I think this is all you need. This is the most important piece of slide. We cannot bother you with Bessel. Bessel function is going to be more complicated with a weight function, and the integral of Bessel with f is very troublesome unless you know something about their derivatives, since in that nature. That's why the author and I don't bother you with Fourier Bessel series representation. But I just want to let you know this kind of problem can exist. We use Bessel function of the same order, Jn. If we want to represent any arbitrary function, essentially the function given in this section, you can represent by Bessel function. And the coefficients can be obtained by using this formula. Now, without knowing how to integrate Bessel functions, it's difficult to assign homework for Bessel, Fourier Bessel representation. But the Fourier Legendre is relatively easy. You integrate a polynomial with another polynomial. If you have access to MathCAD, is a piece of cake. You let Mascat to do all the hard work. So can you do the homework problem for this section 11.6?
That makes more sense, sir. Yeah.
Very good. Very good. Thank you. Okay. Any question relate to the next section? No question? I can tell you,
I haven't even gotten that far yet.
there's some of you send me email, voice some concern. I have, I understand it's toward the end of the semester. You know, every year toward the end of April, I told my colleague I would like someone to freeze me up for 1 month and wake me up in the middle of May after the commencement. But the technology has not reached that point yet. Let me see what am I going to do.
It's not so much. I don't think it's so much as
Please,
the technology. It's more of the infrastructure to support that technology. I.e., like internet in the state of Mississippi is non-existent. It's you might have some good internet or none at all. It's neither none of it is in between.
yeah, I understand. Okay, for the homework for next section, look at this problem. This is from study guide. If we want to prove this, now we take a deep breath and see what we can do. What this problem is really, if this is the given function, for x greater than 0, we have this function. We want to prove this equal to this integral, then we can compare. This is the same. We compare, if this is f, we say, okay, f, and this is the Fourier integral representation of the function. It has a cosine, just like the left-hand side of the equation. So then I realize what we are asked to prove is A of W equal to this, the remaining factors, 1 over 1 plus W squared. So this is what the author want us to prove. We want to prove this. Once we prove this, then we can say, okay, the given function f, that's this function, can be represented by this function in this form, Fourier cosine representation with the coefficient equal to this. So what do we need to prove is this equation 2. Then we use the Fourier cosine integral representation. Let me see. I didn't leave it open. Okay, I think I have it in the general summary of concept. You see, this is what I discussed about the Fourier series, no, Fourier integral representation. If we want to represent a given function f, arbitrary given function, any arbitrary, it can be e to the 2x, e times e to the x times sine 2x, it can be anything. Then we can represent this function by this integral. And then the coefficients in the representation will have to be obtained by these two formulas. So in order to prove the problem I just discussed, we are in fact asked to prove one of these two. If it's a cosine function, we are asked to prove this. So we put a given f in there, integrate to prove that indeed the result is 1 plus this was the problem we discussed. E to the, this is a given f. I keep reminding you. This is the given f. Treat this as a given f. And the left-hand side looks similar to Fourier representation. Then we look for the difference. Then we see, aha, this coefficient, 1 over 1 plus w squared is something maybe corresponding to A of w. And B of w equal to 0. So this is all we need to prove. Okay? So this is what I said. If this A of w is this, I can write this because I look at this side. This is the complementary part of the Fourier integral representation. So then I prove, I integrated, I proved in the equation I mentioned, okay, this is the Fourier coefficient. I want to prove this integral give us this. So I integrate, I use table. Where do you find the table, by the way? You should know by now, inside the cover in the textbook, you should see this equation. At the bottom, if you look at the textbook, you just flip in the corner at the bottom. You see these two equations? Okay, so this is where I got this equation. And then I prove stepwisely indeed that the integral equal to 1 over 1 plus w squared. So I said indeed this equal to this given function. Any discussions about this problem? Let me ask you a question. Do you know the difference between Fourier integral and a Fourier series representation. In the final exam, sometimes students are confused. Is this a Fourier series problem or Fourier integral problem? The answer is very simple. What do we look at it? We look at the range of the function.
Look at the range.
It goes, at least one side goes to infinity. That is Fourier integral representation. Don't use Fourier series. Okay? If you start with Fourier series, it's going to be a disaster. You lose most of the points. So this is a point I want to caution you. Don't start solving this problem by using Fourier series, because the range of interest for x goes to infinity.
This is a Fourier integral.
Yes, that's why this is a Fourier integral representation.
Okay.
This is a common confusion from the student in the final exam, so I want to mention this. Any other questions? No question? So can we adjourn the meeting?
Will you be available later today if we have any further questions, Dr. Chen?
Yeah, I'm willing to offer another recitation session if you need me. Today is a busy day because I have an important meeting tomorrow. But if you need me, I can offer another session like this at 5 p.m. Is this okay?
Sounds good.
Yes, sir. Cause I'm working now on the homework, and if I have further questions, it will be good.
Yeah. And I prefer we discuss collectively because some of your questions may be very common to the class.
Yes, sir.
So that's why I'm proposing 5 p.m.
5
Okay.
p.m.
Okay,
today.
I'll make a reservation for 5 p.m. today, and I'll send an announcement to everyone.
Okay, sir. Thank you.
Thank you.
Thank you.
Sure. So meeting adjourned, right?
Yes, sir.
Okay.
Thank you.
Thank you. Yeah.